right, let's finish this up and do problems 19 through 25. Hopefully you're going to think this test is really easy. I guess it depends on your past history with Algebra 1. Okay, 19 says determine the slope of the line represented in the table. Okay, if you're ever given a table, we can simply find the slope by taking the change in y over the change in x. Sometimes you'll see it like this. Change in y over the change in x. So I ask myself, how do you get from negative 3 to negative 2? Well, you go up 1. How do you get from negative 2 to negative 1? You go up 1. How do you get from negative 1 to 0? Up 1, etc. How do you get from 5 to 2? You go down 3. How do you get from 2 to negative 1? Down 3. So in order to calculate this, I take my change in my y, negative 3, over my change in my x, positive 1, and I get that the whole way through the table. So I know this is linear, and I know that that means the slope is negative 3. So change in y over change in x. Okay, number 20 and 21. Let me just cover up 21 for a second. We'll focus on 20 and then we can go to 21. 20 says we're given w is negative 1, 4. We're given that x is 4, 0. We're given that y is negative 5, 1. And we're given that z is 0, negative 3. And they want to know what's true about segment wx and segment yz. Now you could kind of eyeball this and guess, but I want to know for certain. So if these lines are truly parallel, which it looks like they are, they should have the same slope. So I could figure out what the ordered pairs are for this and use my formula y2 minus y1 over x2 minus x1, or I could simply count rise over run like we did earlier. And that's faster, so that's what I'm going to do. To get from line W to line X, instead of rising, I fall, and I fall 1, 2, 3, 4. So that's a negative 4. And I run 1, 2, 3, 4, 5. So that's the slope of segment WX. Now I'm going to find the slope of segment YZ. So instead of rising, I fall 1, 2, 3, 4. So it has a slope of negative 4 over, and then I run 1, 2, 3, 4, 5, and you can see that they have the exact same slope, which means they're parallel. So they looked parallel, but now we've proven it because they both have the same slope, and I know that parallel lines have to have the same slope. Okay, let's look over here at 21. 21 says that BC is perpendicular to segment RS. Which of the following could be the slopes of the two line segments if plotted on a coordinate grid? Okay, so I know if these lines are perpendicular that the slopes are opposite reciprocals. All you have to do is look at these answer choices and see which of these numbers are opposite reciprocals. And it is D. Answer choice A, those are reciprocals, but they're not opposites. To be opposites, one's got to be positive and one's got to be negative. On answer choice B, they are opposites, but they're not reciprocals, because if I flipped 4 over 1 over, I'd get 1 over 4, and that's not what this says. C, well, these aren't opposites, nor are they reciprocals. D's the one I want. Remember, negative 7 is understood to be over a 1, so if I flip it over and switch the sign, voila, I get 1/7. So opposites, one has to be positive, one has to be negative. And reciprocals, you need to flip it over. Flip and switch. Okay, number 22 down here. Says, which of the following equations represents a line perpendicular to the graph of this equation? So I identify my slope, which is negative 5. And if I want the perpendicular slope, I just flip and switch. So when I flip the fraction over and I switch the sign, I get a positive 1/5. And you'll see that answer choice G has a slope of positive 1/5. So it is the one that would be perpendicular to it. Okay, we're cruising now, not much left to go. All right, let's look at number 23. 23, we are told the endpoints of AC, and it says that A has an ordered pair of -2, 1, and C has an ordered pair of 3, 3. And it says if point B is graphed such that it's the midpoint of segment AC, then what are the coordinates of point B? So I know B should be somewhere in here, eyeballing it. And if I want to know exactly what it is, I just follow the formula where you add your x's, divide by 2, add your y's, divide by 2. Very simple. We've already seen a few problems like this. And you can see that you get a midpoint of 1/2, 2. Let me just graph that. I go right a half and up 2. Does that look like B is the middle of that line segment? Sure does. Okay, let's look over at 24. 24 says the line below passes through the points -2, 4, it's down here, and 3, 5, which is up here. And it says, which of these equations best represents a line parallel to this line? Okay, if I want a line parallel to this, I want a line to have the same slope as this one right here. So I'm going to count my slope, and I'm going to count rise over run. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is my rise. And 1, 2, 3, 4, 5. 5 is my run. So my slope of this line is 9 over 5. And if a line is going to be parallel to it, it has to have the exact same slope. So looking at our answer choices, answer choice D is the only one that has a slope of 9/5. Okay, and the last one. 25 says, in the grid below, draw a line that is perpendicular to the line and passes through the origin. Okay, if I want a line to be perpendicular to this, I want the slope to be the opposite reciprocal. So first I need to figure out the slope of this line. So I look very carefully to see where the line goes through a corner of a box, which looks like right there, and right here. And the slope is 1, 2, 3. I went down 3, so the slope's -3. And right 1, 2, 3, 4. So if this line has a slope of -3/4, the perpendicular line will have a slope that's the opposite reciprocal. Flip switch, 4/3 would be the slope of the perpendicular line. And if I want it to go through the origin, then I want it to go through 0, 0. And so to graph a line with slope of 4/3, I just go up 4, right 3, up 4, right 3, and I just draw my line, and there it is. That's what the line should look like if it's going to be perpendicular to the one they gave us and goes through the origin. That wasn't so bad. Let's give it a smiley face. Hopefully you're all ready for your test, and you will do wonderful.